Well, welcome back guys now to our next exciting episode in the series of looking at how to solve trig equations. So what we're going to be doing today is, just swap to the blackboard here, we're going to have a look at how to find the general solution to trig equations and also have a look and see, well, what does that actually mean. So as with a lot of this work, I think the best way to do this is to actually work through an example. So let's say we're asked to find the general solution to this trig equation. Now, as we looked at last time, if I actually just go back on, well, we'll go back to the desktop for the moment. What I've got graphed here is the sine function and the line y equals a half. So as you might recall, what we were trying to solve was when does sine x equal 0.5? Well, if you have a look at the graph, one of the solutions we're going to get would be this point here. Why? Because if I drop that down there, whatever this x value is, whatever that is, this will be when y is equal to a half. So that solution can simply be found by taking the inverse sine of 0.5, and if that was done in degrees, you'd find out that x was equal to 30 degrees. And 30 degrees is equal to pi over 6 radians. Okay, and so our solution is pi over 6. Now this is one solution at the moment, obviously. So this is not a general solution, it's called a particular solution. Now what we wanted to get basically is a way of telling us what all the solutions are. So we've got another solution over here, another solution here, and so on. And not only those that we can see here, but if we went to that direction or back over this direction, we actually end up with an infinite number of solutions. So to describe that infinite number of solutions, we'd need some sort of equation where, depending on what we substitute into it, we end up with these different particular solutions. And that solution might also be used to say, well, maybe we want all the solutions between, say, negative 2 pi and positive 2 pi. Well, we want those 1, 2, 3, 4 solutions. Maybe this general solution can help us get these 4 particular solutions. So how would we go about doing that? Well, one thing I'm going to get you to look at here is using the graph, how we can end up with a pattern to these solutions. Okay guys, as you might notice, the screen has changed quite a bit here. What I've done is I've decided to not work in radians for the moment, because working in degrees is going to be a little bit easier to see the pattern of our solutions. So we've still got our sine function here, but in degrees here I've gone from 0 up to 720 degrees and down to negative 720. And we're still having a look at trying to find all the solutions to that equation, y equals sine x is equal to 0.5. So let's have a look at some patterns that we've got here. Okay, so here was our basic solution that we got before. If you take the inverse sine of 0.5 and you do that in degrees, you end up with 30 degrees. In radians, that would be pi over 6, but let's work in degrees just for now. Now another solution you might see is this one here. Okay, so that is 150 degrees. If you look at the symmetry of this section of the graph, hopefully that's clear why that is. Just change that to a different color for a moment, because this here is 180 degrees. And this from 0 was up 30 degrees in that direction. Look at the symmetry of that shape, so this must be 30 degrees down from 180. Okay, then we've got this other point here, which if you're getting familiar with the sine curve, you might recognize as 360. So this other solution here is going to be 30 degrees up from that. And so that would be 390, which I'll put in a minute on the graph. This point here would be 360 plus 180, so 540 degrees. So this other solution must be 30 degrees below that. So let's put that in the same color as the other ones. So this is going to be 390 degrees as a solution, and 540 take away 30 will be 510 degrees. Now I've done the same thing over here but in the negative direction. Okay, so we've got these points here, which are negative 180 minus 30 degrees in that direction, 360 degrees, negative 360 plus 30, negative 540 minus 30, and this point negative 720, negative in front of it, which I'm running out of screen, so I'll just move that in a fraction. So that point there is negative 720 plus 30. Okay, so let's once again let's just see the pattern going on here. So this solution here could be described as 0 lots of 180 plus 30. This solution here, the 150, could be described as 1 lot of 180 minus 30. The solution here, 390, well 360 is 2 lots of 180 degrees, then we're going to go plus 30. The solution here, 540, is 3 lots of 180 minus 30. And now if you look at that pattern, you might predict another solution, which we can't see at the moment because it's over there somewhere, would probably be 4 times 180. Okay, now we're going plus 30 minus 30 plus 30 minus 30, so this has to be plus 30. It fits the pattern. Go back the other way, does that pattern still hold? I think it does. This would be negative 180, negative 1 times 180. Let's make that clearer. So negative 1 times 180, and that is minus 30. The solution here, solution here, negative 2 lots of 180 plus 30. Okay, so here, so negative 360 in other words, plus 30. The solution here, okay, well the pattern would say negative 3 times 180, that's a negative 540, and go on plus 30 here, minus 30, plus 30, so minus 30. Does that fit? Yes it does. So negative 540 minus 30. The solution here, okay, negative 4 times 180 would be the negative 720, and then we're going to add 30. Okay, so how can we generalize that? Well, you might recognize that the numbers 0, 1, 2, 3, 4, and then down this way, negative 1, negative 2, -3, -4. Well, they're just the integers. Okay, so that's set of integers set of numbers that you've met before, etc. onwards. So could we use that? Well, yes, we could. Let's call n an integer. So n is an element of the set of integers. That weird looking e is a means element of, means as a member of this group of numbers here. And we're multiplying n by 180. And then we're adding or subtracting 30. Now, how do I sort of do something which goes plus then minus and plus then minus? Well, one way we can do that is using the powers of -1. If you make -1 to the power of n, where n is still that integer, well, if n is equal to 0, that would become 0, which is, sorry, that's not correct. It's going to equal 1, because anything to the power of 0 is equal to 1. And if you make n equal to 1, say, then we would get -1. If you make n equal to 2, so -1 squared, you get +1 again. N equal to 3, you end up with this being equal to -1. And the same thing works with negative numbers, and you can try that on your calculator. -1 to the power of -1. Okay, what would that equal? Well, let's just check it. Grab my calculator, so -1 to the power of -1. Hey, that's -1. And if n is equal to -2, okay, you get +1. So it looks like it works for any odd number. Okay, 1, -1, as in called -1 odd. 3, you always get a minus. Whereas even any even one, even if it's a negative, okay, comes +1. So maybe we can go plus -1 to the power of n times that 30. Would that work? Would that give the x solutions? I think so. Make n 0, 0 times 180, that would become equal to +1, so plus 30. That's what we're getting here. And if you make n equal to -1, so +1, let's get the solution here. You get 1 times 180, that's this here. That would become -1 to the power of 1. So what is that? Well, that's -1. So you end up with -30, which is this solution. Let's go down to say -1, this solution here, in -1. So -1 times 180, that's that. -1 to the power of -1, that's -1. So -1 times 30 is -30. Yeah, so it looks like we have this pattern here. And that is basically going to hold for any sine function. We're going to have this kind of pattern of alternating, adding or subtracting values. Now, this value, this is really important here, because this is the one that we want to add or subtract from our, lots of 180. And this is known in mathematical terms as the principal value. Okay, so we end up with, we could generalize this as 180 n plus -1 to the power of n times whatever our PV is. Okay, so this here is going to be our general solution. Well, with the 30 degrees in it. So this particular case times 30 degrees. Or if we were doing this in radians, which often we are, convert the PV to radians and we end up times pi over 6. Okay, guys, we'll need to look at some other cases, okay, we've got other more complicated sort of sine equations, but we're going to see that they always basically fit this kind of pattern here. And then we've got to look at, well, what do we do for cosine? What do we do if it's a tangent? Well, we'll see that they are going to fit a similar sort of pattern. In fact, their equations are going to be a little bit more easy to see the pattern in this alternating, adding and subtracting. But we will look at this together with some more complicated examples of sine ones tomorrow in class. Okay, I would suggest that maybe if you need to have another look at that video, this video, if that's causing any confusion, and come ready to class tomorrow with any questions or things about this that you didn't quite understand.